Understand the target variable. To calculate the molar mass, m, of the unknown gas, we must use the relationship m equals m over n, where m is the mass of the collected gas sample and n is the number of moles of that gas. Determine how to find the mass. M, the unknown gas, is released directly from a pressurized cylinder into the collection tube. The mass of the gas sample collected is determined by measuring the difference between the initial mass of the cylinder before the gas is released and the final mass of the cylinder after collection is complete, option D. Determine how to find the moles. And to find the number of moles of the collected gas, we use the ideal gas law equation. N equals P gas V over RT. The volume, V, of the gas is read directly from the graduated markings on the gas collection tube, option C. The absolute temperature, T, of the gas is assumed to be equal to the temperature of the water bath once thermal equilibrium is reached, which is measured with a thermometer, option B. R is the standard molar gas constant. Determine how to find the dry gas pressure, P gas. Because the gas is collected over water, it is saturated with water vapor. By Dalton's law of partial pressures, the total pressure inside the tube is P total equals P gas plus pH2O. Adjusting the tube so that the water levels inside and outside are equalized ensures that the total pressure inside the tube is exactly equal to the barometric atmospheric pressure outside. P total equals PATM. Thus, P gas equals PATM, pH2O. To calculate P gas, we must measure the atmospheric pressure using a laboratory barometer, option A, and look up the equilibrium vapor pressure of water, pH2O, at the measured water temperature, option B. Identify the unnecessary measurement. The mass of the water in the apparatus, option E, does not affect the mass of the gas released, the volume of gas collected, the temperature, or any of the pressure calculations. Therefore, this measurement is completely unnecessary to calculate the molar mass, making option E the correct answer to this except question. The correct answer is option E, mass of the water in the apparatus.